graph represents the relationship between the electrical power and the current in the resistor that obeys Ohm's law. So your answer should be choice number 3. It's a direct relationship between power and current. So as power increases, so does your current, which is going to show a direct relationship in the amount of voltage that is being produced, which is what your line is representing. Okay, question number 2. Question number 2 says a potential drop of 50 volts is measured across a 250 ohm resistor. What is the power developed in the resistor? So we need to figure out what power is, which is P equals I times V. Power, we need the current and we need the voltage. Well, we have 50 volts, we know that. And we also know that we have a resistance of 250 ohms. So the one thing that we do not know in order to find the power is the current. So to find the current, though, we have to use Ohm's law, which is voltage equals current times resistance. So voltage is 50, which equals your current times the resistance, which is 250. So we're going to divide 50 divided by 250, and that gives you a current of 0.2 amps. So we have our current now, so we're going to plug that in and find power. Power equals 0.2 amps. Multiply that by the voltage, which is 50 volts, and you should have a power rating of 10 watts. And that's choice number 3. Okay, question number 8. In the simple electric circuit, a 24 ohm resistor is connected across a 6-volt battery. What is the current? So again, I equals V divided by R when I rearrange it. So 6 volts divided by the resistance, which is 24 ohms, and you get 0.25 amps. Okay. Same thing, we're going to do question number 10. The current through a 10 ohm resistor is 1.2 amperes. What is the potential difference across the resistor? So if they're saying potential difference, that means they're just talking about the voltage. So voltage equals I times R, again for Ohm's law, which means we're just taking 10 ohms times 1.2 amps, and that gives you a voltage of 12. Okay, a little bit more challenging question. We're going to go to question number 21. 21 says that we have a 100 ohm resistor, so resistance is equal to 100 ohms, and an unknown resistor are connected in a series to a 10 volt battery. So we know our voltage is 10 volts. If the potential drop across the 100 ohm resistor is 4 volts, so this has a 4 volt drop, the resistance of the unknown resistor is. So we're looking for what the resistance of the unknown resistor, which I'm going to call R2. So if I draw this out, I have one resistor, a second resistor. This resistor, we'll say, is 100 ohms, and 4 volts of the 10 volts gets dropped off there. The resistance here is unknown, and we don't know what's being dropped off there yet. Now, I can determine what's being dropped off there because I have 10 volts and 4 volts. So that means because this is a series circuit, the voltage gets split up, so whatever remains is what gets dropped off. So if this is 4 volts, that means this is getting 6 volts. The next thing that you have to figure out is pretty much if I'm trying to find resistance. If I'm trying to find resistance, that means it equals voltage over current. Well, we know the voltage, which in this case for this resistor is 6. We have to figure out the current. The good thing about a series circuit is that current is the same throughout each of the resistors because the current doesn't change. So I can figure out the current based on this resistor, and then I can use that for this one. So 100 ohms is our resistance, and we have 4 volts, and so we're going to do 4 divided by 100 ohms, and that's going to give you a current of 0.04 amps. choice number 3. So you really have to understand how a series circuit works in order to determine how you're going to set up your equations to find your solutions. Okay, and the last one we're going to do is question number 42. Question number 42 says to calculate the resistance of a 900 watt toaster operated at 120 volts, which is the US standard for a household outlet. So if we're looking at this, calculate the resistance at 900 watt toaster. So we know that power is equal to 900 watts and the voltage is 120. We need to calculate the resistance of the 900 watt toaster. So in order to calculate the resistance, again, remember you need voltage and current. We know the voltage, but we don't know the current. In order to find the current, we're going to have to use the power equation, which is P equals V times I, which means we need to figure out what the current is. So power is 900, voltage is 120 times the current. So 900 divided by 120, and that's going to give you 7.5 amps, which is your current. That means that you can now plug this into your Ohm's law, where resistance is equal to 120 volts divided by the current, which is 7.5 amps, and resistance is equal to 16 ohms.